You know, the Pythagorean theorem is arguably the most important theorem of mathematics and certainly the most important theorem in geometry. It really is the foundation for so much of what we see, what we measure, what we understand, and it's an amazing, amazing fact. And it really just revolves around right triangles. And it basically says that if you have a right triangle, and you know the lengths of the two legs, A and B, and you know the length of the hypotenuse, C, then if you take the square of the lengths of the legs and add them together, you will always equal the square of the hypotenuse. A squared plus B squared equals C squared. Let's take a look at some examples. So here's the first one I want us to chew on. I've got a right triangle indicated by the little square angle here. And the legs are sides 11 and x, and 13 is the hypotenuse. And the question is, what is x? Well, since it's a right triangle, I know that the lengths of the sides have to conform to the Pythagorean theorem, and so I'm off and running. Because I can now say that x squared plus the other leg squared, which is 11 squared, or 121, has to equal the square of the length of the hypotenuse. Well, 13 squared is 169. And so now I have a nice little equation to solve. X squared, if I now subtract 121 from both sides, I see x squared equals 48. Now, technically, when I have an equation that is a quadratic, x squared in it, we know there's two solutions, plus or minus the square root. But in these geometrical questions, x here is representing a length. Length cannot be negative, so in this particular context, I can just take the positive square root and report the answer as the length of x is square root of 48. Now let's see if we can simplify that as much as possible by pulling out as many perfect square factors as we can. Well, 48 is really 16 times 3, and the square root of 16 is actually 4, so I can write this as 4 square root of 3. So x equals 4 square root of 3. Pretty cool. Let's try another one. Pythagorean theorem. I gotta tell you, this is my favorite theorem. This is it. You're wondering, gee, Professor Berger, what's your favorite theorem? You know what? Wonder no more. This is it. All right, here we have a right triangle, although it's sort of funny that the hypotenuse is kind of the thing here on the base, but that's okay. We look for the right angle. That tells us where everything is. And this is x plus 2, and that's 8. Can we actually figure out what x equals and what all the sides are? Well, sure we can. Pythagorean theorem. So we know that x squared, the leg squared, plus the other leg squared, which is 8 squared, or 64, has to equal the hypotenuse squared, which is the quantity x plus 2 squared. Classic mistake is to say that this equals x squared plus 2 squared. But remember, we have to FOIL. There's going to be those inside and outside terms. So in fact, FOILing that out is going to be a little bit more work, but we'll get it correct. So when we FOIL this out, first times the first is x squared. The outside terms will be a 2x. The inside terms will be another 2x. When we add them, we get a 4x. And 2 times 2 is 4. So we add on a 4 at the very end. Now notice that if I subtract x squared from both sides, they actually cancel. So this potential quadratic-looking equation turns out to actually not even be quadratic at all. I'll just subtract 4 from both sides to get rid of that constant there, and I'll see 60 equals 4x. If I divide both sides by 4, I see that x equals 15. So x equals 15. So that's 15. If you actually want to know what the hypotenuse is, the hypotenuse would be 2 more than 15, also known as 17.